Do y'all get a notification that recording started? Okay. There is a thing where I mean, you should not record people ever really without their permission in a private setting like this. Um, don't be a jerk. Okay. Can anybody remember last week when we were in the classroom together and I pointed out one of the a couple of the weaknesses of a hash table? Does anybody remember that? Any of those weaknesses we mentioned? I see it was highly memorable. It was a long time ago. It feels a long time ago in emotions as well. Um, nothing. You remember one of the things I said was, oh, Ryan, yeah,
They are rather space inefficient.
they are
That's one thing
space
I remember.
inefficient. Yes. So that means they take up a lot of space in memory relative to how much space they actually need. Um, and we kind of motivated that by thinking about how they need all those empty spots, as it were. They need a lot of empty spots. So when you do any operations, you don't have a bunch of collisions. If you have collisions, collisions are bad. They slow you down. So if two things hash to the same thing, then then you're going to have trouble either. You have to do more work to add items, to look up items, to remove items. And then that works against the whole point of a hash table was to have constant time complexity. Okay. Um, does anybody remember the other kind of downside to a hash table? That's right. We said that hash tables don't do range operations. They don't have any idea of being sorted. So if you let's imagine this scenario, which I've started coding here. Can y'all see my code okay? Hey, tell me this. Uh, hang on. I see Zoom has this new thing. Um, you can see my screen at full screen, right? You can see my code, right? Yes. I can also make it so that it's like above my head to the right, like a real YouTuber. Would you prefer to see it that way? So you have to see my face too? Cecily, you were too kind. Um, I thought it was cool that I could do it though. Hang on, I'm gonna stop. Let me just, so like apparently I can do this. It can be over my shoulder. Is that what? Thank you, Bo. It's weird. Yeah. Is it readable? It's got to be smaller, right? It's really important that we get this right. I don't know how we're going to make any progress today if we don't get the right format here. Tristan, thoughts? You could go either way. Ethan, you have thoughts. Wait, you can draw on it?
Is that me doing the drawing?
It's not me.
Can everyone see that?
Hey, I didn't know that was a thing. So we now have a giant whiteboard. Hmm. Well, that could be misused. Uh,
Did it clear?
it did clear. Yeah. Wow, that's cool. Wait, can I do that too then? Is that annotate? That's me in orange. Yeah. Well, that's kind of cool. Let me find the clear button now. Clear all drawings. Okay. Uh, that's fun, but okay. Hang on. Let me. It's probably better if it's bigger so you can actually see my screen, isn't it? Okay. So back to what I was saying. Space inefficiency is an issue. The other issue is what if we wanted to do something like find the next thing or find a range of things that are sorted? So I'm imagining a scenario where you've typed out the beginning of a word and you'd like to autocomplete the rest of that word for the user. Does that make sense? So you've experienced this anytime you've gone to Google where you type in how do I, and then Google auto suggests something. Yeah. Now we're not going to be that advanced, but we are going to say if you were to start a word like PA, there's a lot of words that a lot of letters that could come next, right? We could say the Patriots or I don't know, Papa as in John's or P-A-T just for Pat, like the person or the verb. So autocomplete is what I'm thinking about as the motivated example for this. So I want us to make a word set. This is the interface for a word set. It has these three things, an add and a remove and a contains, which are really three operations that a dictionary would do really well. Yeah. We know we can do all of that in essentially constant time with the dictionary. But notice these other four methods that I've listed here. So next takes in a word and returns the next word in our word set in basically alphabetical order. The fancy word for this is lexicographic. So lexicographic essentially just means alphabetical. So if we had a set of words, we could give one word and it would return the next word. Does that make sense? In alphabetical order. Same for previous. We could get the previous word. I have made both of these string question mark, which means nullable, because it might be that if you ask for a previous word and you're the first word in the set, then there is no previous. And equivalently for next. Okay. This prefix, though, is kind of our, to me, this is the key method that you would want for doing autocomplete. So this prefix method takes in a prefix. So the prefix are the beginning letters of the word. It takes in an integer k, which is how many words you want returned. And then it returns this thing that's called an IEnumerable of string. IEnumerable is really just it's a more general way of returning kind of like a set of things. So this is for many ways, the preferred way. It's kind of the most flexible way of returning something that you could iterate over. And it makes it easy, this return type kind of makes it more efficient for the computer. But if it helps, you can just think about IEnumerable as just a list. So this is like a list of strings that start with this letter, these letters that are in prefix, and int k says, I want k of them. So you could say, if we were going to call this, we could call prefix, or maybe we could say words. Here, let me, var words is equal to prefix. I can't actually code this here. And like I was saying before, if I put in PA and then 10, this would find the 10 words in our set of words. It would find 10 of them that start with PA, the first 10. Does that make sense? And lastly, we have this method that's also an IEnumerable. And notice it takes in, it's called range, and it gets all of the strings, all the words that are between the low and the high given words. And we say we only want k of them. So if there happen to be more than k, we'll just take the first k. So this would be like us saying give me all of the words between PA and let me actually put something in pad and I don't know, snow. Oh, this would be better. Give me all the words between ice and snow, but not more than 40. Does that line make sense? So this is the ice is the low, snow is the high word, and then 40 is our K, the biggest one to get. So I want to make sure, do these methods make sense so far? Um, so I think I already have this written here. Well, I've said it. If we're going to implement this with essentially a hash table, a dictionary. In order to get all of the items between ice and snow from a hash table, how many how much work do we have to do in big O terms? So if we want to find all of the words that are lexicographically between ice and snow, up to 40, how much work do we have to do? Ryan, you got a thought?
Would it be O of 1 because there's a maximum of 40?
I think it's actually worse than that because we don't know where any of them are. But good thinking on the 40. Like we don't know where ice is. So how many times are we going to have to look at all of our words? Like we have to look through the whole list, the whole set of keys, because we can't trust the order. There is no order to a hash table.
I guess that would make it a O of N.
So that would be O of N. Exactly. Yes. Very good. So what I'd like us to try to do in this kind of starter lab is to implement this interface, the HashWordSet, using a hash set, which is what's kind of appropriate for like that's going to be like our hash table. And then we're going to implement it a second way where we use a data structure that uses that has ordering information. And then we're going to time the usage of these to see if we can actually see that one is faster than the other. We can analyze it and understand the big O terms. And I would also like to see if we can feel that in time. Okay. Okay. So I am going to be sharing this code with you and asking you to do some additional work with it. I think for today, I wonder if you could actually just watch me code and interrupt me. You don't have to raise your hand, just ask the question because it's hard for me to see. If you have questions, I want you to understand this code so that you can operate in this code base. Okay, so I have created, hang on. No, did I do that backwards? Yes. Okay, hang on. This this is going to be my implementation. So we're going to implement the iWord set, that word set that has the range search, the prefix search, the previous and the next. And we're going to do it with like a dictionary, with a hash table. I don't know if we used this last semester, but I think I mentioned it. A dictionary is inherently a key value pair. Yes? Key value pairs, remember keys and values. For what we're doing, we don't need values. We really just have keys. We just really have, these are the words that are kind of like in our language. So either words are in the language or they're not. So we don't really need a dictionary because a dictionary is more than what we need. Does that make sense? Like we don't have a value in this example. I just really want to say, maybe an example up here. Y'all can read my text, right? This text is big enough.
A question, by the way. Is it
Yeah.
supposed to be hash set word set or just hash word set, like the title of the code?
Oh, I went back and forth on this name. It feels weird to have the word set in it twice, but I think, no, thank you, Ryan. I think I do like it better. I'm going to call it hash word set. You know, I have a thing about naming, right? Uh, but really, we're going to use a hash set to implement the word set. And I almost really want to emphasize that twice. So let's do our words here. So we've got Cecily and Ryan and Bo and Caleb. Okay, so I'm just gonna do that. Now I want to make some more words that have shared prefixes. So Rye is gonna have a shared prefix with Ryan. Beautiful, right? That's the same as Bo, right? Bo? You and beautiful have the same start. Um, what's that, Bo? I didn't hear you. Uh,
Yeah, that's right.
that's right. Okay, good deal. I know probably a lot of people call you beautiful, Bo. I'm not the first to think that. Um, I guess we could say kale, but misspelled. Uh, and let's see, what starts with CE? Is there any other words that start with CEC? I can do CE. Cephas, I don't know. Okay, so what I'm trying to do is set it up so that we can put in a prefix and get some things out. Let's see. Can y'all think of any other words here we could add to our word set that would share some prefixes?
Could do
You could do,
serpent. You go first.
I was going to say you could do rhinoceros from Ryan, but that's a
Is
big
it
word.
isn't it Rhi, RHI? Okay, we'll still put it
You're
in.
gonna spell it.
I could misspell it, yes. Somebody else said something?
You could do servant, like a deer. Are you familiar with that word?
What's the word?
Servant.
Servant?
Servant. It's the term for deer, moose, and elk.
Oh, I don't know that word. How do you spell it?
Cervid.
Cerbid? Wow.
See it. The camera's in the way.
Oh,
No, it's a V instead of a B.
Cervid. Okay. Thank you for teaching us.
Sorry.
I guess we should do one more okay, I've got CRB. Let's put in like one more in the middle. Um, we can put in Ethan and
Ethernet.
Ethanet.
Ethanol.
Oh, let's just do Ethel. Uh, okay, so what I'm trying to show you here, I can put it on multiple lines. Imagine this is not code, but imagine this is our word set. Okay. So this is going to be our word set for now. Maybe comment it out so it'll compile. I really just have this set of words. I do not have a value associated with each one. Really, their presence in the set is the only value that I'm storing. So the data structure that I'm going to use is called a hash set. And a hash set, this will be of strings. A hash set is going to store all of the words by hashing them into a table. So that will make it really quick to do insert and lookup and delete, which we have those operations. We need those operations. But this is my underlying data structure. And because I'm thinking about it, let's go ahead and instantiate a new private hash set of words. Whenever we instantiate this hash word set. Okay, I have not implemented this interface. So I'm going to click here. So it'll at least give me an implementation for add contains next, previous range. I am going to move remove to the top. You see they put it in alphabetical order. But to me, it makes sense that this add remove next be here. Okay, so how do we add a word to our hash set? You ready for this? Words.add word. That's the essence of it. Yes. Now, let's see. I think the way this is designed, they want me to this interface wants me to return true if the word was already there and false if it wasn't. You with me? So we can, I think, yeah, you see that the hash sets add also returns bool, so I can just return the result of that. You ready for contains? You ready? So this part is easy and slick because these three operations exactly match onto a hash set. To do contains, I essentially want to say words dot contains the word. Now, and then I want to return, I can return that same thing. Here's what I want to emphasize that's a little bit invisible that I hope we can find with our, we're going to time this, like we'll run this for 1,000 times with a bunch of words in the hash set and see how slow it is. But underneath the hood, this hash set really is doing hashing. So that means it can do add, contains, and remove in constant time. But it's going to take up more space. But it should be really fast to do these three operations, which are super fast on a hash set. Does that make sense? So, like, remember one of the main lessons that I want you to learn from this class and the previous class is we got lots of data structures and algorithms. When's the appropriate time to use them? And if you do a lot of adds, contains, and removes exclusively, then a hash set is definitely the way to go. Okay, so in this case, I want to return words dot remove the word that was given. So in this case, I've just exactly implemented, implemented these operations, add, contains, and remove on the hash set. So that's boring and essentially close to done. It bothers me that next and previous are not next to each other because of the alphabetic. So I think I'm going to change these and put them in this order. Yeah. Okay. So I guess all these are about the same. So let's try one. Okay. The key to this fundamental limitation of this hash set is when we get the keys out, they're not going to be sorted in any order. They're going to be all jumbled up. So because they're jumbled up, because we can't trust the order of the keys that we get out, we're going to have to search the whole, like, essentially list that we get. So let's do prefix first. So prefix. Essentially what I want to do here is I want to get all of the items. So I don't really want to use words again because I already have the word words. The items are words dot, and then let me see what this is called. Mm, I may actually have to iterate over it. Yeah. Okay. Let me do this. I think I can do it like this. I can say for each var word in words. Yeah. Okay, so I'm going to iterate over every single item in the hash set, which you could imagine are all of these guys. All right. For each one, I'm going to see if it matches our test, which is essentially, does it start with prefix? So let me go ahead up top and say, I would like to have I would like to have some results. Going to say var results is equal to, and this is going to be, I think I can just make it a new list of string. Okay, so I've got this empty list of words. I'm going to add the words that match. And then down here, I'm going to return the results. Yeah, this is a pretty standard setup for doing a search. So what I'd like to do, I know I got a little bit more here. I need to check to see that they start with the prefix. And then at the end, I need to make sure that I only return K of them. So for each of these, I want to say if the word, I'm pretty sure starts with is a built-in. And I want to say if it starts with the prefix, then I just found a word with the right prefix. So I'm going to say results.add the word. You good with that so far? To make this correct, like if I do this now, these results will not be in alphabetical order because they weren't in alphabetical order to begin with. As I found them, and I found that they did in fact start with prefix, they'll be here. They'll be added, but they won't be in alphabetical order. So I really need to sort the array, and then I need to remove the first K of them. Does that make sense? So, I think there is a sort method on a list, and it sorts the list in place. You see that it doesn't return anything. It's that's going to sort those results. And now, in Python, you'd call this slicing. There is this slice method. Is that really that's not gonna work. Okay, that works. For now, let me try this. So you see the slice is saying, take a list of strings going from a start value to an end, a start index to an end index, and just return those. So I think this is an implementation of our prefix. I haven't tested it. So if we were to call prefix with with CE, then we would get Cecily and Cephas and Servid. And notice, those are in alphabetical order, aren't they? Hang on. I want to break this a little bit. If they were stored in this order, we would still get them in the exact same order that they were in the hash set, which is not in alphabetical order until I sorted them. All right. Oh, I need to put in a number here, so I could put in 10. And if I put in 10, I need to handle that better. What if there aren't 10 things in it? That's going to break. So really down here, I need to say this is the math.min. The smaller of the two, either k minus 1 or results.count. Does that make sense? So if you've only got 4 things, or if your results are, in our case, if we got 3 things in the, if we have 3 results, but we ask for 10, we can't give 10, we can only give 3. So it's the smaller of however many things were in the results and what was asked for. Actually, I might be off by 1 here. Should this be minus 1? Oh, wait, this is start and length. Start and length. Hang on, start and length, not start and end index. So I don't have to do the minus 1. So it's either, it can be K and results.count. Okay. Okay. So this is a way for us to get, we're manually going over every word in the whole hash set, checking to see if it's prefixed, the prefix matches, adding the ones that match, sorting the results in alphabetical order, and then slicing off as many as we want. Okay, what questions do you have about this?
I was actually thinking about taking, would it be possible to take inspiration from linked lists in order to like link each word to its next alphabetical thing?
Well, hold that thought, because we're gonna improve this. This is where we're going to with trees. So if we have a binary search tree, we're gonna be able to do this much better. So what I'm trying to expose here are the weaknesses of hash tables. So let's see if we can do the either previous or next to kind of end on that. So let's see. I don't know. Let's go next. So my idea on next, again, we're going to be going through all of the items in non-alphabetical order. We're going to be given some word that might or might not be in the list. So if I wanted to find the, so this would be like our, what do we call this? Hash word set dot next. And if I put in, if I put in RYE, what would be the next word? That comes before it. That comes before it. That comes before it. That is the word, so that doesn't count. Before. Hey, before. So we just found the situation where there is no next. So this should return null. You with me? So let's try something else. How about Ethan? What comes after Ethan? So what we're really going to do is iterate over this non-ordered set. Does Ryan come after Ethan? It does. It's the best one we found so far. You with me? All right, so we need to remember that Ryan is our best yet. Does Bo come after Ethan? No. Caleb? No. RYE? Yes. Is RYE closer to Ethan than our current best, Ryan? It's not. Um, we could, beautiful comes before, after. Does Rhino come after Ethan? Yes. Does it come before our current best? It does, doesn't it? Because RH comes before RY. Does this make sense? So we're still doing just comparisons. This comes before, this comes before. Ethan is Ethan. So that doesn't come after. And then Ethel does come after Ethan. And it comes before our current best, which is RYE. Yes? Does this make sense? Now,
Our best was Rhino.
oh, Rhino. Yeah, you're right, right. Yeah, we found a better one. So um, I think of these that process that I just painfully went through. How much work did I do? Um, I definitely went through the whole list. So what would you call that? The whole set. Start to the big O. Anybody want to guess their favorite big O time complexity? What do you think, Ryan?
I think it's O of N, because you just have to check every individual word.
Yes. So we just did big O of N work, which I think is the best case we could do here. Note though, like naively, if you wanted to be lazy, you could just sort the whole list and which is already I'll give you this tidbit that we're going to learn for real later. You can't sort a list really. Really, the best case time for sorting a list is n log n, and n log n is worse than n. So we don't really have to sort the whole thing just to figure out what comes next. We can do it in one pass using using the algorithm that I described. Just what's your current best, and then every time you find a new value that comes after the word, we compare it to the current best. And then at the end, you return what your best was. Does that make sense? So we are able to find the next word in one pass through the list, which is O of N, which in our case is a tiny amount of work because there's just like 12 things, 12 words in the array. The array. I mean, we're iterating over the keys, the items in the hash set, like a list. Okay. Okay. Y'all still with me? We try to finish this thing in the next 8 minutes. Okay. So I'm going to say string question mark best is equal to null. So I want to say, I don't know what the best value is. I'm going to start it to be null, and then I'm going to look for better best. Maybe just look for a best. I'm going to say better best. Okay, so I'm going to look for a better best by saying for each var word in the words. Oh, sorry. You see, I use the word here. Can I call it candidate? Is that okay? It's like a possibility. Maybe just W. You okay with W? I know you guys care deeply about the naming of things like me, and I take by your silence that you're equally bothered by this. Okay, let's see if we can get this right. I want to say this is for next. I would like it to be the case. So in this case, the word that we passed in, like our example, is Ethan. If Ethan is less than W, and immediately we have an issue. Do you see the issue here? The operator less than cannot be applied to two operands of type string. Do you remember how to get around this? Negative? Didn't we do this last semester? I think we have a compare to method that is built in. You guys remember compare to? So this is going to compare one string to another string. It's going to return less than 0 if word comes before W. It's going to return 0 if they're in the same exact position. And it's going to return greater than 0 if this word comes after this word. If word comes after W. Didn't we do this? Yes. Okay. So I really want to look at the sign of this word. So it's kind of saying if that is less than 0. So just for that's essentially like saying if we had greater than less than, I'm saying if word is less than W. I believe that's equivalent. That's our condition there. But remember, we had two conditions. When have we found a new best? It's if the current W is better than the best, is less than the best. Okay. So it's sort of like saying if the word is less than W and the W is less than the best. Yeah. Okay. In order to do this correctly, this is going to be a little syntactically gross. So hang with me, okay? Are you with me? I can do this ampersand. This is my and, but this condition, I need to do two things. One, I need to make sure that if best is null, this means we've never found a best before. And in this case, then we definitely want to get in here because what's in here is basically saying best is W. All right, so if best is null, or if the W dot compare to best is less than 0. I might have that backwards. Maybe this is greater than 0. I want to say that the W, yeah, I think it's this way. Yeah, I think that's right. Okay, so I need to test this and confirm, but this is kind of our complex condition to update the best. At the end of this, we return the best. This would be our best next. The best word that comes after the current word. Whew. That was something right there. Okay, what questions do you have about this? It's really something, isn't it? Mm-hmm. So any questions or comments here? Ronaldo, you still out there? I saw a flash of him. He's there.
Yeah.
Okay. So you know what I want you to do, right? I would like y'all to write previous, which is just like next, but opposite. And I would like y'all to write range. Um, and I think I'm okay with however you want to do it. I mean, not however, like I meant algorithmically. I would really like you to do this with your brain and not ask AI to do it, which I'm confident it'll do a really good job of. Um, and then I am going to write some code to test this data structure, and we're going to see how fast or slow it is. So to me, I mean, I can send you some unit tests, but it's less that the unit tests are just to confirm it actually is doing what it's supposed to do. But to me, the point of this assignment is we're going to do it like this, and then we're going to redo it using a sorted set. And the sorted set is going to be under the hood implemented with a binary search tree. And hopefully, by using a binary search tree, which does inherently store order, we can do previous and next and prefix and range much more quickly, taking advantage of the order that is embedded in that binary search tree. Was everybody able to watch those videos of Rob Edwards? I signed those, right? Any feedback or concerns on those?
My Wi-Fi was out during that time, so I didn't get submitted on time, but
Oh.
I can watch them today.
That's all good. I understand Wi-Fi has been pretty disappointing on campus. I will be assigning more of his videos. Let's see. Wait, can you see my whole? Hang on. Can you just see my VS Code? Okay. Okay. So as you're watching him do his amazing work, what we're seeing is definitely where we're going, which is, and we're going there quickly. The solution to this problem that I'm belaboring today, that hash tables, as amazing as they are with time complexity of 1, are not nearly they can't be good at everything. And one of the things they're not good at is this kind of sorted stuff. Can you still hear me when my dog barks, or is it like nothing? Yeah, he's annoying. He won't let anyone walk on our street. Um, okay. So when do y'all hang on? Harry. Here, buddy. Harry, it's okay, man. Okay. Okay. So this is Harry. Say hello, Harry. Yeah, he probably will be angry if he sees you. Um, okay. When would be a reasonable time to have this code done? Um, you think you could have it done beginning of class Thursday?
Did you just say next Thursday?
I was saying like this Thursday.
This Thursday?
I think I know what to take from your laughter, but I would be happy for you to voice what you're thinking. That's what I'm asking for. What's like end of day Thursday? So we'll have another day to talk about stuff. What do we think? Ethan, thoughts? You look joyful as well. Okay.
I mean, I could probably have it done Thursday, but I don't really want to.
I mean, I feel you. I have the ice laziness too, but don't we need to like we got to do stuff, right? Like
I guess it depends on when you post the assignment. Like if you forget to post it until Thursday morning, then
I mean, that's valid and fair. Uh so what if I post it like today before noon? That is my goal. So to be clear,
maybe.
this is implementing the two methods. We did next, so it would be previous, and that range search, which is going through and saying find all of the items essentially greater than or equal to low and less than or equal to high in alphabetical order, but not more than K things. Does that seem reasonable to get this done by like 11:59 p.m. Thursday? Because I'm assuming that if you're here, you have power and Wi-Fi. Um, that's correct. Is that correct? Um, but I certainly don't expect anybody to endanger their life by traveling when they're not comfortable, if you're not on campus or whatever. Uh, what are the odds that we have in-person classes Thursday? Charity says no. Mhm. I feel like we got like good 50-60% chance. You think?
I hope not.
Okay. Um, okay. So, uh, so I want to work on getting this posted, and then after I post it, was that Caleb? You look absolutely bovine. Uh, hmm. Uh, After I post it, I'll work on some basic, like me and ChatGPT will work on some unit tests so we can confirm that our stuff does work. Um, but the point here is not just to make it work, but then we're going to test it. So this is what you don't do. You don't have to do ahead of time. But we're going to run it on like a big set of words. And time, how long it takes to run on your computer. And everybody's computer will be different. Uh, but we're going to get kind of a baseline for how long this code takes to run in time after having analyzed its hypothetically, like, right, theoretically, we know it's going to be linear time complexity. And then after this, like on Thursday, we'll set up and start the second part, which is what it would look like to do this with essentially a binary search tree, only it's not a binary search tree that we're going to make. We're going to use Microsoft's. So please reach out and utilize the Discord as you have questions. I really am much more open. Like, I would love for you to collaborate with another human being and not outsource this to AI for this assignment. That even that level of, it's not exactly your work when you work with somebody else, but I think you can both be learning. But I think there's a lot less learning that happens when AI does it for us. So that is my AI usage request policy expectation for this assignment, is that you do these by yourself. And I guess that the AI usage would only be for you to ask after you've really made a strong effort and actually struggled some, what's wrong with this? Um, but hopefully, like, really, if when you run the unit test, you'll be able to see, is this right, or is this working or not? Okay. Thank you for being with me today. I still don't like Zoom. I like being in the same room with you guys. So I do miss that and feel like I'm crippled here. Uh, I'll get this to you. We'll do the standard GitHub Classroom thing so that you can download, a copy of my repo. And, well, do you want to do it that way? Have you guys ever used branches in GitHub? Uh, I saw one yes, but probably that's not enough. Okay. We should learn that before we are thrown into it. So we'll do it the GitHub Classroom way. And the full assignment, this is really just like the first half of it. But the full assignment won't be due until like next week. But I am saying, let's get this dictionary part done by Thursday so that you have that part under your belt and have an understanding of what's going on before we kind of redo the assignment with a different data structure that is kind of more mysterious, more new. Okay. Well, y'all feel free. If got a question or something, always email Discord. If you want to hang around on this call, I'll wait to the end. If you want to talk face to face. But hope it's a good day. Be safe out there. Make good decisions. Blessings, guys.